do you need help?
Yeah, so we're learning about the urinary system, and I'm not sure if I understand how the proximal convoluted tubule works.
Okay, so I see here that you drew out your diagram, which is nice. So let's okay. So the nephron is the workhorse of the kidney, right? So we're gonna start out with the glomerulus corpuscle, right? And then we're gonna have the proximal convoluted tubule, and proximal because it is closest to the corpuscle. And do you know what its purpose is to begin with?
Isn't it involved in the reabsorption of nutrients?
Correct. It's involved in reabsorption of nutrients, and actually it's 100% of our nutrients that's going to be reabsorbed here. So nutrients like glucose, amino acids, vitamins, and ions. Now, how are these nutrients absorbed? How are they transported?
By secondary active transport?
Right. So if you recall from Biology 430, what does active transport require?
Energy?
Right. In form of?
ATP?
Yes, so we need ATP because, as you recall, we have a concentration gradient. If we were to have a membrane, I'm going to draw it real quick here. So our membrane, we're going to have channels. We're going to have the extracellular fluid and the intracellular fluid. So there's going to be more sodium on the outside than inside, right? Because we're going to be, there's sodium constantly being transported out, and potassium is going to be going in. So ATP does exactly this. It maintains the right concentration of sodium and potassium. Is all of this sounding familiar?
Yeah, a little bit.
Well, think of ATP as a credit card. ATP is basically the fee that has to be paid in order for the concentration gradient to change its shape and let the sodium out and take the potassium in. This is like their ticket. You can't just abort, like you need to pay a fee for it to happen.
So then how exactly are nutrients transported in? Because this is sodium.
Well, sodium is primary active transport, while nutrients are going to be reabsorbed by use of secondary active transport.
So we're also going to use ATP then?
Well, yes, but not directly, because recall that there is another gradient being worked on. Do you remember what it's called?
Does it have to do with the fact that the outside is positive and the inside is negative?
Yeah, there's a term to that, and it's called the electrochemical gradient, which is the difference of electrical charge on each side of the membrane.
I remember this now.
Good. So the primary active transport uses a source of chemical energy to do transportation, which is the ATP that we talked about. While secondary active transport uses an electrochemical gradient, which is generated by active transport. So ATP moves the sodium, then the sodium is going to move the glucose. I'm just using glucose as a nutrient example.
Okay, so secondary active transport is basically just the transport of two different molecules.
And keep in mind that we also have a transport mechanism which is dependent on the number of carriers. So for example, we're going to have a maximum number of glucose carriers and vitamin carriers and so on.
Okay, yeah, that makes sense.
Okay, pop quiz question.
Oh gosh.
Okay, ready? So what kind of transport is water going to use? Primary or secondary active transport?
None.
Why?
Well, isn't water just going to diffuse through osmosis?
Yes, good job. It's going to use passive transport because water chases salt. And remember that keep in mind that only 60 through 70% of it is going to be absorbed passively, because the rest is going to be reabsorbed in the loops of Henle and the distal convoluted tubule. But seriously, I encourage you to continue to draw out your pictures, because it seriously makes it better to be able to imagine it, and it's more effective when studying. Well, I'm going to leave you here, and if you need any more help on the rest of the nephron or anything else, just let me know. The student is learning about the urinary system, specifically about the nephron, which is inside the kidney. The student's learning goal was to understand what occurs in the proximal convoluted tubule, and to be able to understand it, they need to go back to what they learned in Biology 430 about active and passive transport. The technique that I used to access their skill level was asking them questions that they should already know from Biology 430 to make sure they remember it, and I also gave them a pop quiz question towards the end. One of the scaffolding techniques that I used was activating prior knowledge. I like to use this technique because they are able to understand better if they see the bigger picture. So I like to compare science to life examples, like the scenario where I compared ATP as a ticket or a credit card. Another scaffolding technique that I used was giving them mini lessons to move them towards deeper understanding. However, I also gave them time to talk so they could recall and what they already know and be able to apply it to today's lesson. I also use visual aids because, in my opinion, anatomy and physiology is better understood when you can picture it to see what exactly is going on. I also use a technique that goes pause, ask question, pause, and review. I also incorporated growth mindset feedback by praising their work and encouraging them to continue what they're doing, like drawing pictures and so forth, to be able to study the material better and more effectively.